Tableau dimensions versus measures. Hi everyone, this is Voida from Skill Cup, and in this video we will be talking about dimensions and measures in Tableau. So why are we trying to understand the dimensions and measures today? Because even though Tableau is used widely by organizations to make data-directed decisions, some users might find it complicated to understand the correct definition of dimensions and measures in Tableau. This can lead to inaccurate and deceptive visualizations. Let's first begin with defining a dimension. The variables or classifications used to describe the data in the visualization are called dimensions. A field that is an independent variable is known as a dimension. It is usually a field with qualitative information in it, such as the product name. The data in the visualization is used to create measures, which are numerical values. In other words, a field that is a dependent variable is known as a measure. It is usually a field with quantitative information in it, such as sales. Before we begin, we must also keep in mind that Tableau has 7 different data types, which you can see on the screen: the string value, date value, date and time value, numerical value, Boolean value, geographic value, and cluster value. When we first begin working with a dataset, we connect the data to Tableau and it automatically organizes every field into a dimension or measure. To understand the difference between dimensions and measures, we need to create a regulated guideline for the users so that we can produce compelling and valid visualizations. In this video, we will be talking about the definition of dimensions and measures and also the key differences between them. At the very start, let us know that we will be using Tableau Public and our dataset is a sales sample data, as you can see here. We have chosen this dataset since it consists of various types of data ranging from string, date, and geographic to integer data type. The first step is to connect the dataset to Tableau Public. Once our Excel file is connected, we see that the fields have automatically been classified into dimensions and measures. Once the data is connected to Tableau and all fields get sorted according to what kind of information is stored in the fields by Tableau, an icon is also denoted to the fields respective to the data type, which can also be changed manually by the user by clicking on the icon itself. These are the icons representing the data types of every field from our dataset. We can hover over the fields in the data pane. A drop-down appears towards the right corner of the fields, and it can be clicked to describe the field, whether it has been classified as a dimension or a measure. Otherwise, we can go to the worksheet and identify that whether the field is a dimension or a measure by looking at the gray bar between the list of fields towards the left of the worksheet. The fields above the gray line are dimensions. The fields below the gray line are measures. Some examples of dimensions here are product ID, product name, region, and more. So in most cases, dimensions are shown as categorical data in the form of strings, dates, or locations. However, discount, profit, quantity, and sales are some measures here, as you can see. Measures may be used to calculate things like aggregations, ratios, and percentages because they are often represented by continuous fields. Tableau, using its intelligence, categorizes the fields and might also sometimes base the categorization upon the field headers or labels, as we can say. Like we see here that the row ID is a numeric data type but being classified as a dimension. We can also change it to a measure by simply dragging and dropping it below the gray line, and also the other way around. Undo the changes for now. Talking about a few differences, when we pull a measure on the row, we can see that an axis is drawn and our visualization seems more aggregated. there is less detail for us. As we put a dimension on the column, labels are generated, and more detail is added to our visualization. Hence, we say that dimensions add level of detail to the visualization. Dimensions add granularity to our visualization. Let's clear the sheet, add sales to the row once again, and see that a measure such as sales alone does not define anything. We do not know what it is about unless we add a dimension here. Adding subcategory to the column shows that a measure depends upon the sales to be defined, whereas a dimension is independent. Let's clear the sheet again. To find out an aggregate of the total number of orders sent by each shipping mode, we will obviously be using two dimensions. Now, since we know that a dimension itself cannot be aggregated, we convert it into a temporary measure to be able to aggregate it. In our case, we have aggregated it to a count distinct for each shipping mode. We have very few options available for aggregation of a temporary measure, which was originally a string data type. Here you can see. Let's use a measure here instead, like quantity, and in the drop-down you can see that the number of available aggregations are much more. So thank you for watching this video on dimensions versus measures in Tableau. We hope you found it helpful, and if you have any questions or comments, please leave them in the comments section below.